All right, so today we're going to talk about the slope-intercept form of a line of equation. When we say slope-intercept form, it's actually a shorter version of it. It's really slope. What kind of intercept does it give you? It gives you the slope. Which intercept? X-intercept or the Y-intercept? Y-intercept. You guys remember this? So please, the real name, it should really be called the slope Y-intercept form of a linear equation, because if you just say intercept, you don't know which one it is. It's really the y-intercept. By the way, which letter do we use for y-intercept? B. Very good. Do you guys remember that? That's why the slope y-intercept from the linear equation is y equals to mx plus b, right there. Okay. And of course, m stands for the slope. B stands for the y-intercept. Very good. So it's something we already know. We already learned this. A reminder. Okay. So knowing this, today we're going to graph using this slope-intercept form, and we're going to do some other things with it. Okay, that's kind of interesting. You'll see in a minute. Okay. So again, the m is the slope, b is the y-intercept, and m and b are some real numbers, right? Okay. And we already said that this is called slope-intercept form. Saying it again. Okay. Any question on this? Man, move on. Right. M and b are some numbers. What about x and y? What are those? Those are your x and y are the variables in this equation, right? There are two variables in this equation, right? And m and b are some numbers that we're gonna get, which represent, m represents the slope, b represents the y-intercept. Okay. Here is an example. This will be the easiest example you get. It says, find the slope and the y-intercept of y equals to negative 2x plus 1 over 2. Okay. So how would you do this? All right. So somebody tell me the slope of this line. Everyone should be able to tell me the slope. Because, and why is this the easiest question you will ever get? Yes, Amy? Danny? Sorry.
It's in the equation. It like tells you.
Yeah, because this, what kind of form is this written in? Slope, intercept form, isn't it? So we know the slope and the y-intercept right away. Okay, so Annie, what's the answer?
The slope is -2.
Good.
And the y-intercept is 1.
Exactly. Any question? So the m, like I could write slope equals -2, but I could just write m, right? Thank you. M means slope, and then b means the y-intercept. So there you are. Okay. Any question? This the kind of question will be the easiest one that you will see on your homework tonight. Okay, they give you a slope-intercept form. They ask you for the slope and the y-intercept. Very simple, right? By the way, who remembers from last time, for the y-intercept, what must be 0? Which coordinate for y-intercept? X has to be 0, right? So look, when you plug in x equals 0, what do you get? Y equals to half, right? Well, when you gotta plug in x equals 0 before y, right? So you get b equals to half right away when you plug it in like this. So you guys remember finding x and y-intercepts? To find the y-intercept, right? You plug in 0 for x, b for y, right? There it is. Right? You plug in x, right? 0 for x, b for y, you get b equals to half right there. You see how that makes it really easy? Of course, if you want to find the x-intercept, what do you plug in for x? For x-intercept, you plug in a for x, and then? No, not b for y. 0 for y, right? For x-intercept, y has to be 0. You guys remember that? Right? So it's kind of a review for that one too. Okay, let's move on to the next example then. Okay. Actually, let me show you that. So for y-intercept, we know it's going to be 0, comma b, right? For x, right? When you're going to plug in x for 0, y. So let's plug it in. You get b is equal to what? -2 times 0 plus half. What do you get for your b, guys? Half. Do you see how we get b equals to half right there? Right? Isn't that how we find the y-intercept? Again, if I wanted to ask for x-intercept, what's x-intercept? What do you plug in? A comma 0, not 0 comma a comma 0. You guys remember? You could figure it out, but that's later. All right, so let's move on to the next example. Okay. Now, what if I ask you to graph that slope-intercept form? So far we've learned how to graph using tables. Now I'm telling you that knowing slope-intercept form, we could just graph this line without doing a table. Isn't that nice? Okay. So again, what was our slope from this equation? -2. What was our y-intercept? Half. By the way, slope, isn't that a ratio of rise over run? When I say -2, it looks like there's only rise. Where's the run? How do you know that? You're right, it's 1. How do you know? How about Grace? How do I know that the rise is -2 and then run is 1? Exactly. -2 is really as a fraction. What would that be? -2 over 1. Very good. Right, guys? By the way, -2 over 1, isn't that same as, could we multiply top and bottom by -1? Isn't that same as 2 over -1? Doesn't matter which one we use?
Nope.
No. -2 over 1 is same as 2 over -1, which is equal to -2. Alright, so how are we going to graph this? So here's our graph paper. And of course, a lot of you are using graph paper, which is really nice. So, step 1. Anybody know what to do? Step 1. To use step 1. Step 1 is, write this down, plot. Anybody know what we need to plot? Plot the y-intercept. Okay, that's our step 1. Whenever you have a slope-intercept form, you need to plot the y-intercept. Okay, do we know how to plot the y-intercept? Yes, we do. Where is it? Where would the y-intercept be? Yes. 1/2. On which axis?
On the y.
1 y-axis. Exactly. So where's half? In between 1 and 0, right here. So there's our step 1. Just easy, right? Isn't this nice? Because you know this y-intercept, you know where to start, right? Y-intercept tells you where to start. Isn't that right? Okay. By the way, why can't we start with the slope? Why do we have to start with the y-intercept? Because, you know, we got the slope also. Any idea as to why we can't start with the slope? Because we can't, okay? Why not? I want you to discuss with your group. Go ahead, everybody. Why can't we start with the slope? All right, how about Ria? Why can't we start with the slope? What did you guys discuss?
Well, you can't start with the slope because it's kind of confusing.
Okay, well, let's start with this one first. All right, the reason is because if you know that the slope is -2, you don't have a what? Yes, starting point, right? If I didn't have this, right, and I said, okay, draw the slope of -2, you go down 2 to the right one, right? Well, where are you going to start at? You don't know where this line is going to be, right? Right? Do I start at 0, 0? Do I start at 1, 1? Where do I start, right? That's why we don't know where to start, right? So we need a starting point, which would be what? The y-intercept. So we know here's our point. We know this point belongs to the line, doesn't it? Right? Because that line is going to hit the y-axis at half. So we have a starting point. In order to use a slope, you need a starting point, right? From this starting point, now step 2, use the slope to what? Find the other point. I'm going to say points. You could actually find a point or points. Okay, it doesn't matter. Okay, find the other point. Okay, so let me show you how to do that. Anybody remember from last year what we do from here? Okay, no one does? Jonathan.
Well, you get the point and then, like with last night's homework, then you do kind of like that right triangle, and then using a ruler, you draw a line through.
Exactly. So because I know that this point, remember slope was constant everywhere, right? So from this point, we know I could go down to, you guys remember how to find the slope from the graph? It's sort of that way, right? So let me move it up. So you go what? It's negative, let's do -2 over 1. I go down 2, and then, so I go down 2, and then what? To the right, how much? Right, 1, right here. So I go down 2 to the right 1. There's my second point. Right? Do you see that? Also, what else could I do? I could go from that point, y-intercept, what else could I do? I could go up to, let me do that in a different color. Up to, oops, different color. Go up to, and then what? To the left one. You see where I end up? And of course, all I have to do is what? How many points? Could I keep going? You see from this point, could I go down 2 to the left one again? Yeah, I could go. How many points could I find using this? Many as many as you want. I just need 3. I think 3 would be nice. So I'm going to connect these. You can do this as many times as you like. This one is it's not really nice because my y-intercept started at half, right? it doesn't really like fit into the grid. It's not going to happen every time, but if it does fit into the grid, it'll be a little bit nicer. But it's okay. We could still deal with this. Okay. Half is not that bad. If it was like 5 over 6, that would be kind of bad. You know what I mean? But half is not too bad. There you go. There's my line, right? Do you see how I started at the y-intercept and use the slope to find the other points? Yes?
Yeah.
Can you do something like this? Does this sort of remind you of stuff that you did in intro? Because you've done this many times in intro, right? Okay, so let's do some more examples like this, okay? Here we go. So why don't you try example 2? It says, use only the slope and the y-intercept to graph y equals to x minus 3. This time it's a little bit easier because it's going to fit right on the grid, unlike the other one. The other one, you know. Anyway, go ahead, everybody try this. I'll wait. Okay. By the way, what's our slope? M is equal to? Hey, I don't say anything, but that means there's invisible 1. So slope is 1 over 1. What's your y-intercept? Negative 3, right? It's not 3, is it? It's because y equals mx plus b. So if you want, you could rewrite this as y equals to 1x plus negative 3. Maybe it's better to write it this way. Okay. Does that make sense? You could see it a lot easier if you do that, right? Anyway, go ahead, everybody, go ahead and draw graph, okay? All right, Sabrina, tell me where to start. What's my starting point? Step 1 is to look at your notes. What's our step 1?
Step 1 is to plot.
Plot the what? Y-intercept. Good. So what's my y-intercept?
-3.
So what do I do?
Go to 0, -3.
Good. 0, -3, which is going to be the y-axis, right? Because that's what y-intercept is. The line is going to go through that point. Isn't that right? Thank you. So line is going to go through that point. Then what? My slope is? Yes. Step 2 is to use the slope to find the other points, right? So I go what? From here?
You go
Up 1 to the right 1. I want to find another point. What could I do if I want to find another point? What's 1 over 1 same as?
Negative.
-1 over -1, right? That's still 1, isn't that right? So what does that mean? I could go down 1 to the left. So if I do this, should all these points line up? If they don't, guess what? You did something wrong, okay? They should line up, right? Because we know this is a linear equation, right? The slope intercept form gives you a line when you graph. Okay, so how many people got? Let me draw this. Okay, do you think I should just do this? Is this good enough? No, please extend it and what? Draw arrows, because you could plug in any numbers you want, right? There are infinitely many order pairs, right? That are solution to this linear equation, correct? So there you are. Okay, any question? How many people got this graph? Raise your hand. All right, good. All right. Question is, could we have done it using the x and y intercept? You know, doing a little bit of a table and so forth, find 2 points. Yeah, of course. But turns out, if you use slope intercept form, it's much easier to graph because you know the slope and the y intercept. You don't have to do any tables or anything like that. Basically, you don't have to do much math, right? You just plot the point, the y intercept. Then from there, you just follow the slope to find the other points. Okay. By the way, from here, could I go up 1 to the right 1 again? Do I get the other point? Yeah, I could keep doing this, right? So I could find as many points as I want, especially if it's like nice this way, where like it fits right on the grid so well, right? Does that make sense? All right, let's move on to the next example then. Okay. So now on your homework, what if they give you not in a slope intercept form, but as a standard form, something like 4x plus 3y equals to -9? What should you do? And they ask you to graph using slope and the y-intercept only, or something like that. Anybody have any idea? What should we do if they give you an equation that's in slope intercept form? Some people over here only. Okay, I want you to discuss with your group. What do you guys think? What are you gonna do to graph this line using slope intercept form? Okay, what do you do? So how about, what did your team come up with? Kyle, what did you guys think? If they ask you to graph this using slope intercept form?
You subtract 4x to the first.
Yeah, exactly. What are you trying to do? You're trying to solve for? And rewrite this as a?
Equation.
Yeah, which form do you want to write? So we just have to basically what? Rewrite this as what?
Slope intercept.
As a slope intercept form. Guys, do we know how to do this? Haven't we already been doing this? When did we do this? When did we change these things to slope intercept form, guys? Huh? Yeah, when did we do that? You guys remember? No one remembers doing this? Okay, when do we, okay, we say 4x plus 3y equals negative 9. Kira, we're going to subtract both sides by 4x, right? And when we do, what do we get? 3y equals to? Good. I like how you put negative 4x minus 9 first. Why do you think I didn't write it as negative 9 plus negative 4x? Yeah, we want to have what first? Which term? X. One with the x, because that's how it's going to be a slope-intercept form, right? Then divide both sides by 3, right?
Yeah.
Y equals to negative 4x. Oops. Negative 4 over 3x. What? Minus 3. Does that make sense? When do we do this, guys? You guys remember doing this? No one remembers doing this?
Yeah. I remember doing
Who? What? Okay, Nora. When did we do this? In this chapter.
section 1.
Yeah, section 1. When we were doing the table of values, remember we solved for y, didn't we?
Yeah.
Right? So it's the same thing. Now we even know a better way after we solve for y, just like we've done this many times, right? When we're doing the tables of values. Remember, this is what we did, and then plug in a bunch of x's, right? Nice values of x's, and figure out the points. Now all we need to do is graph this. We don't have to do tables, right? We could just graph it now. So let's graph this. Y equals to. Let's graph this now. Oops. Let's graph y equals to negative 4 over 3x minus 3, right? Do you know how to graph? Okay, go ahead, everybody try. So basically, I am asking you to graph. What was it? 4x plus 3y minus 9. 4x plus 3y minus 9 equals negative 9. And of course, you have to rewrite this as a slope-intercept form. As y equals to negative 4 over 3x minus 3. Okay, you see how easy that becomes, right? Once you rewrite it as a slope-intercept form, we know how to graph. Everybody go ahead and try. Go away. All right. Daniel, tell me what to do to graph this. So if they ever give it to you in standard form, you just have to change it to slope-intercept form, right? And we've done this many times, right? In our first section when we were doing tables, right? So in this equation, what's our slope, Daniel? So we got y equals to negative 4/3 x minus 3. What's the slope in this equation? Say it again. Yeah, negative 4 over 3, right? It's the coefficient of the x, right? Whatever multiplying the x in this form is the slope. Isn't that really nice? What's our y-intercept? Negative 3. And step 1 is to use what first? Plot what first? Y-intercept. So tell me what to do? Plot. How do I plot y-intercept? Yeah, 0, negative 3 right there, right? It's going to hit the y-axis at negative 3, right? Everybody okay with that? Okay, there you are. Okay, so then we got negative 3 over here. Then what do we do next here? How about James? Tell me what to do next. Step 2 is to what? After we plot the point, step 2 is to? Go down 4. Yeah, go down 4. Do I have enough space? Oh, good, I do. Okay, 1, 2, 3, 4, and then what? Go right 3. I'm right at the edge, but I do have a right space. Right, enough space. Yeah. So then, let's find another point. If I could do negative 4, 3, what else could I do, class? 4 over negative 3. So let's start from here. Go up how much?
4.
1, 2, 3, 4. And then go to the left. 1, 2, 3. There you go. Right, you start always, you're going to start at the y-intercept, right? How many people got this? Let me graph the line here. Am I done here? No, we need to connect them and draw arrows. Okay, extend this. Draw arrow. This one I don't have much space, so I'm just going to do this. All right, any question? How many people got this graph? Raise your hand. Is this easy or hard? Easy. Okay, is this easier than doing tables? Yes, it is. Okay, then why do I show you the table method? Well, because you still need to know that. Okay, later there's some nice thing about doing tables and stuff like that. Okay, is because when you get an equation that you don't recognize, right? If it's not linear equation, only method you know how to do so far is to do tables. Okay? But linear equations, we got some ways of doing it differently. Okay, are we okay with this? And also on the test, I'm going to ask you to do both ways because you need to know both ways. All right, let's move on to the next example then. Okay? So I want to show you something here. What I want to do is I want to plot some lines. So let me do this equation with this, it allows me to put in an equation. Okay, it already has y equals 2 because it says y equals to f of x, right? You see that? Okay, I'm going to plot in 2x plus 3. Do you see my line right there? Okay? Yeah? I'm going to plot another point. Okay, let me duplicate that. And instead of 2x plus 3, I want to have the same exact line, but I want to intercept at -2. What can I do so that it's the same exact line with the same slope, but the line would go through -2? Anybody know what to do? How to do that? Yes. 2x plus -2. Right? There you go. Right? What do you guys notice about these two lines? They are parallel. Why do you think they're parallel?
They have the same slope.
They have the same slope. Isn't that nice? I could even do something more interesting. Let me edit this. Instead of 2, I'm going to plug in m. Okay. And click OK. Oops, it became a horizontal line. Let me edit this and put m again here. Again, it became a horizontal line. Anybody see why both of these lines became horizontal lines? Guess what the value of m right now is? 0, because when m is 0, you get horizontal lines, right? Well, all lines are straight. You get horizontal line. But here's something interesting. I can animate this. Go to animate, individual, go to m. Look what happens if I change the value of m to 2 again. What's their slope? 2. Right. What happens? And look at both of the lines. They are still parallel because they have the same slope, right? What if I change it to -2? What happens? It's the other way around. It's still 2. I could actually make it move by itself. Okay. I could plug in any values of m. Let me slow it down a little bit. So what it's doing is it's plugging some values of m, right, from negative to positive. What's happening though? These two lines remain parallel. Isn't that interesting? So what do you know about two parallel lines? They must have same slope, but they do have to have a different what? Different y-intercept, because if they have the same y-intercept and the same slope, what? Guess what? Those two lines are? They're the same line, okay? So, you know. So here, write this down. Here's the fact, okay? Same, if two lines are parallel, then they have the same what? Slope and different y-intercept. If they have the same slope and the y-intercept, they're the same line, right? So write that down. Fact 1. If two lines are parallel, then they have the same slope and different y-intercept. Okay, write it down. Okay. Right, here's fact 2. What if the two lines are perpendicular? By the way, what does that mean if two lines are perpendicular? They make what kind of angle? 90 degrees, right? Okay, if two lines are perpendicular, then the product of their slope is, does anybody know what, when you multiply their, this is always true. One person knows? Remembers from? 2? All right, and no one else? Okay, no one will remember.
Okay, the first one is like a reciprocal.
No? Jonathan?
-1.
Thank you. Their product is -1, turns out. So write that down. Okay. If two lines are perpendicular, then their product of their slope is -1. So write this down. This is a fact, okay? So I'll wait for you. Write it down. Okay, let's see whether that's true. Isn't this really nice to do this thing? So what I'm going to do is I'm going to change this to, instead of m, if this is true, what should I change the other one to? What is the, what can you multiply m so that it becomes -1? -1? Okay, let me do this a little bit differently. How about instead of m, I'm going to change this to 2. Oops. Okay, so let me change this to 2. Okay, let me just change this to 2 again. Now, I want these two lines to be perpendicular. So what can I change? What can I do to the second line so that they're perpendicular? 2 times what gives you -1? Yes. -1/2, right? Right? You need to change that 2 into -1/2. Let's see what happens when we do this. -1/2. Anybody have any guess? The two lines will be? There you go. Are they perpendicular? Yes? Okay, so if I change this one of them to m, what should I change the other one to? So that they're always perpendicular. -1/m. Isn't that right? M times -1/m, right? What's reciprocal of m? 1/m. When you multiply reciprocal and the number, you get 1, right? But we don't want 1. We want it to be -1. So instead of reciprocal, we need the opposite of that reciprocal. That's what some of you were saying. So we need -1/m, which is the opposite reciprocal, right? I think a lot of you have heard of this. Let's see what happens, and let's change the value of m. look at what happens. They remain perpendicular throughout. Isn't that right? Even if I change any values of m, I won't. And you notice it really goes really fast right on top. And you might know why it does that. It goes. You see how it reaches up higher and it goes really fast? Anybody know why that might be happening? Because what do you know about a vertical line? What's the slope of a vertical line? It's undefined. And do you think computer could put something that's undefined on the graph? That's why it skips it right away really fast. Because vertical line, the slope is undefined, right? So it doesn't know what to do with undefined number. Okay, anyway. All right, so let's write this down. So what do we write for this? We wrote this. If two lines are perpendicular, then product of their slope is -1, except for which lines? There's except for horizontal and what? Vertical. Why not? Why can't we multiply these slope and get -1? What's the slope of a horizontal line? 0. What's the slope of a vertical line? Can you multiply 0 with undefined? You can. Undefined number, you don't even know what. Okay, it's undefined. So therefore, that's one exception. But what do you know about a horizontal line and a vertical line? The slope is, the two lines are perpendicular, right? If you have a horizontal line and a vertical line, right, they're always perpendicular. So that's one exception. But everything else, right, if the lines are not horizontal or vertical, their product of their slope is -1. And write this down too. So if my slope is 2/3, and do you guys remember what this upside down T represent? It means perpendicular. So if the slope of one is 2/3, one must be the slope of the other line. If they are perpendicular, -2/3. Opposite, reciprocal, right? What's reciprocal of 2/3, guys? 3/2. When you multiply the number and the reciprocal, you get +1. We want it equal to -1, so it's opposite reciprocal. What about if it's 3? One must be the slope of the other line. Negative? No. Yes. Oh, it should be 3/2. Thank you. It should be 3/2. Thank you, Nicole. I almost made a mistake. What about the slope of the other one? If I put -3, slope of the other one, if they're perpendicular, must be 1/3 is correct, right? So they have to be opposite what? Reciprocal. So if it's A, one must be the slope of the other one, -1/A. Any question? Okay, listen, hold on. So if I wanna show that the two lines are parallel, all you have to do is show that the two slopes are same. How do I do that? Well, write each of these equations into which form? Slope-intercept form, right? Slope-intercept form. What if I want to show that the two lines are perpendicular? Again, write each of them in slope-intercept form and multiply their slope, and it should come out to what? -1. Does that make sense? That's how you show it. Yes? Have a great day, guys.